So we have today, the program focuses on neurosciences, artificial intelligence, robotics, natural language processing as different from the other NLP. And we have two people here who I have been working with for about a year or more on various fronts. They are startup founders, Satya and Soumya. I think both are with a neuroscience background. One of them specializes in natural language programming and stuff, if I'm not mistaken, but they can introduce themselves in a few minutes. We started work, which we'll cover secondarily, because Magda is the star of the show today, and therefore we need to focus on her. We started working on how to apply artificial intelligence, robotics, and natural language processing to the coaching framework. And where we started was to work on assessment techniques where we could use their skills in terms of creating an algorithm which would enable us to do, say, robotic assessment, if that's the right word. We've made quite a bit of progress, but we are not still quite there. The confidence level, the accuracy level that we required, something like 95+%. We aren't yet there, but we would get there. We understand what's holding us back. We are working on it. In the meantime, Satya and Soumya started their startup, and they started working on measuring brainwave patterns using various kind of electrodes, caps, and all that kind of stuff. And they were planning to use it for multiple things. A few months ago, they came back and said they had got funding. They started working on it. They have developed a system which would monitor emotions based on one's speech pattern, the vocalization. Today, and again, we can go into a little bit more detail. There are tools available there. I know many of you have used them, which are based on, for example, Google has a tool which analyzes the words, the spellings, or the meanings, or whatever, and then associates them with emotions. There are today tools which would look at facial expressions and be able to tell you what emotions are being expressed. However, as far as I know, and perhaps if some of you do know, you might like to come up and say that in the chat, that there isn't one which would listen to a recording and to be able to say what kind of an emotion is being projected. It's still in the early stages, but they would explain to you as we go along. And the other two are pretty straightforward. That means you can already look at the words and be able to say, hey, these words are happy words or sad words or frustrating words or whatever the words are, what are the emotions which are being conveyed through that, the verbal communication in any language. The second is through the facial ones. And then when it combines with the vocalization, as it were, the non-verbal communication, it's pretty close to as close as you can get to be able to watch someone, hear someone, the words that they say, and to be able to divine in a way something they themselves may not be consciously be aware of. So it takes awareness to a far deeper level than what many people today talk about as deep listening and all kinds of stuff. The word deep listening doesn't mean anything to me anymore if you really can put these together and you're able to look at a conversation. How exactly are we going to use it? I don't know. Whether it's going to be used or misused, I don't know. But it's going to be there out there. You cannot ignore it. And it's up to us to decide what is it that we can make best use of these for. So what we're going to do today is a bit of a dog and pony show. That they're going to start up a link which they have developed, and Magda had yesterday demonstrated with Satya. And as she speaks in response to certain things that you might put up there, and I repeat that to her and talk to her about certain things which really gets her on a high, And I won't talk about certain things which may not. So we will be able to measure the emotional responses of Magda based on that in terms of how the recording comes up in response to certain situations and how they can be used, what you can use it for, all that we will enter into discussion later. So let me stop the introduction out here. So may I request Satya and Soumya to briefly introduce yourself and say what is it that we are going to witness in a few moments with Magda as the star muppet in this show.
Yes, thank you, Ram. I think you summarized the whole thing pretty well. I will quickly give a little bit of a background of who we are, because that sets up the stage as to why we are even doing what we're doing. So I come from a PhD in neuroscience background, and in my PhD, I've been looking at brain activity when you learn new kind of correlations, when you learn to associate something, associative learning, basically, what happens in a particular part of the brain. But this was all deep brain imaging. But I wanted to work with human beings. In that situation, you can't drill a hole in somebody's head, so you need to be as non-invasive as possible. And that's where my uh, my collaboration with Satya started. So we have to leverage the power of AI and the expertise in AI that Satya has. He'll talk about that in order to understand the very, very complicated signals that come out of a human brain, very complicated behavior that human beings can exude. And number two, without being invasive, despite having rather poor signal to noise ratios as compared to deep brain recordings, how can we use neuroscience to actually affect and change in a positive way lives of people out there? So that was my goal, to take this learning from the lab to the world. And the bridge that bridges the gap is the supreme power of AI that we are seeing today, and the expertise that Satya brings to the table. Satya, if you would talk a little bit about your side of the story.
So what we have developed as of now is basically a software that listens very intuitively to what you say, the way you say it, irrespective of the language that you're speaking it, the way there are certain vocal tonalities that goes in a male and female voice. It very intently listens. It figures out what is the emotion that your voice is exuding as you speak in real time. And added to that, what we also do is, so if there is a speaker who is trying to talk to a large audience, with that particular voice signature, what kind of an engagement would the speaker expect the audience to have? So that is both of them in tandem running across as the AI works on a person's voice. And anyone who is trying to correct their voice can do it at a very real-time runtime scale. And so we are very good at understanding if there is a mistake, especially with the voice part. If there is a mistake and there is a very low engagement for the listeners, we can, within a fraction of a second, we can change our voice tonalities. And this is something that the software does. It picks up in very real time what's going out in our voice. What are we saying in terms of tonalities, and how is the listener perceiving our voice to be?
Yeah, right, Satya. Thanks for that.
Would you like?
Let me just add one.
To take this thing forward in terms of session with Magda, Soumya, you or
Yeah.
Okay.
Yeah, I can go ahead. So, Magda, I've sent you a link. If you click on that, and while you do it, and you can maybe share the screen so people can see what the AI thinks of your voice and your emotions. Okay. So I'll quickly add that one of the things we wanted was that AIs today can optimize a lot of things, and that's great. But what we wanted AI to do was to empathize. Empathy is, our ability to understand what another human is thinking or feeling. So we wanted to bring in the power of cognitive neuroscience and the stupendous power that AI has today to be able to figure out from human face, voice, anything. Like if you see someone or hear someone who's sad, you know in an instant that they're sad or they're happy. We want AI to do that, just so that it can understand human beings better. And then there are endless possibilities. So we see a future where AI has empathy. This is a small step, the first step in that direction, and there'll be many, many more to come. So Magda, if you may.
Yeah, sorry, I just have to interrupt Magda over. Magda, could you please click on that address bar of yours where it's written tracken.in? Yeah, could you double click on that, please?
What do you want me to do?
Yes, could you please double click? I just wanted to see if there is an HTTPS written over there.
Oh, there isn't.
So give me a second. I'll HTTP.
I know.
Yes.
Just fat fingers.
Yes, now that works perfect.
And sweaty, like I'm actually nervous.
Wonderful.
There we are.
Yes. So yeah, and so what we have done lately is distinguish male voice from female voice. That has increased the efficiency of the algorithm to some extent. So Magda, if you're ready, just click record.
As ready as I'm gonna be. Hold on.
Somebody says he can sense Magda's nervous energy, but now let's see if the AI can sense Magda's nervousness or fear or whatever you might call it. Okay, just
I don't know
say
what
something.
it
How
is.
do you feel? Magda, how do you
How
feel?
do I feel? I feel I'm excited and nervous. I think I'm more excited than nervous because, but I am definitely sweating. Yeah, I don't know. It's just funny because I don't really get nervous about this stuff. It's like I'm an open book and always have been. So yeah, I'm just a little shocked at this.
Well, the AI certainly thinks that you are happy. I mean, the happiness is always evident in your voice, and there's a little bit of surprise that it's catching. So what the AI does, let me quickly say. So up in the panel that everybody's seeing right now, there's a host of different emotions that the AI can detect. But when you scroll down, what that little red line shows is the engagement, perceived engagement level of people who are listening to her, right? And I'll tell you a little bit more about how we got that a bit later. But Satya, could you mention the different kind of emotions that that Tracken can catch nowadays?
Before that, can we have some fun with Magda?
Okay. I think that's a good idea.
Fine.
I think that's a good idea.
Okay, Ram.
Is
Trigger
Sailor
me.
with you, Magda?
Of course he is.
What's he going to do now?
Oh, sick.
Is he able
right now he's
to see what you're doing?
stretching. Well, he's like, Magda, why are you talking to me? I'm trying to take a nap. But no, Sailor's always with me because he's lovely and amazing and wonderful. And Ram, nice way to try to catch me out. When we had the practice session yesterday, guess who I talked about when I talked about this? Sailor.
Yeah, right. Okay. So Sailor makes you happy. So when you talk about Sailor, what you should be registering is happiness in a big way. Okay, fine.
Yes.
Yeah. Yeah, Satya, you wanted to say something. Yeah.
Yeah. So so right now this is catching the 6 basic emotions. So anger, happiness, surprise, disgust, sadness, and fear. As we go along in the next version, we will have another 10 emotions as granular as apologetic, energetic, encouraging. So there are specific voice signatures as different between happiness and encouraging that AI can pick up. So we are working on this next level of emotion detection where we are putting in another 8 emotions that we can very distinctly catch. That's a big surprise for us right now. And we're very excited to actually put these 14 emotions all across in one frame and figure out that how does our voice responds to it.
That's really cool.
So right now what's happening is that So right now what's happening, the AI is still getting used to your voice, Magda. But over time it gets better. It
Okay.
learns what are the typical intonations of your voice, etc., etc. So there's a lot of personalization that can happen.
So it learns I'm not always happy, and then it goes like, nope, I was wrong. She pretty much is always excitable and happy.
Magda, let us test that out.
Yes.
Say a few words about what you think about your former president.
Oh my God. Cool. Ram, you know me way too well. Like, holy crap. I hate him. I hate him, and I hate him. And I would have taken one for the team to basically get rid of him if I had the opportunity. That's how much I hate him. He is disgusting. He is gross. He is misogynistic. Like, you really know how to trigger me. Like, I really, seriously, like the second I didn't even say his name, and like I can't formulate sentences, and like I get in my chest. So yeah, the AI clearly is not very good at the happiness bit, because there's no happiness here. No,
So
he is a terrible human being.
Is it picking up Magda's emotions at this point in time, Satya, Soumya?
Yes. So the thing is, like I said, it requires some. So if you notice that compared to the rest of us and rest of humanity, I guess, Magda's voice has a very upward inflection. Always has a sort of bubbliness in the voice. So the AI needs to understand that that doesn't always mean that she's happy, even if that upward inflection exists while she's talking about, that doesn't mean she's happy. So it requires a little bit of time to figure that out. If I may quickly answer some of the questions that people say, background. So somebody asked, like, what does that mean? So even when we are talking, there are things happening in the background. There's some sound here and there. There's some sound here
Good
and
point.
there.
Good point. Someone just said maybe Magda is happy when she speaks of the ex-president, but she doesn't realize it. Yes, she's happy because he's gone.
So the thing is, so there's a lot of noise that happens in the background, and the AI can figure out, and we have fed a lot of background noise to the AI. The sound of hacksaw, sound of dogs barking, sound of cars, sound of trains. So the AI has an idea of what all is typically classified as background. So that is what it means when it says background. Some people ask, like, what is this y-axis? So basically they're asking about the red graph below. So what that does is it predicts the listener, so all the people who are present in the webinar, so their engagement levels, how engaged are they based on Magda's voice. They do that, and this is the part I wanted to talk a little bit about, because this is where the hardcore neuroscience really comes in. We as a company went out and actually recorded people's brain activity as they listened to various voices, as they watched lectures, watched whatever YouTube videos they want, did a lot of control experiments. So we ourselves have a brain bank where we have hours and hours of brain activity, and we know what the person was doing. So from brain activity, you can figure out if a person is engaged or not. If you're zoning out, it'll show up on the EEG. If you're very focused, it'll show up on the EEG. And we, using the power of AI, correlated that complex information with various factors in the speaker's voice. So that's why right now we can do something as amazing as this, and I'm very happy that we are, as far as I know, we are the only person who's doing this. Even some of the gold standards in voice computing, they don't have access to this kind of a neuroscience data set. So that's what the y-axis, or what or as somebody was referring to, the red graph below, what that's doing. Right, so I wanted to just clarify that.
Okay. Tommy said, we do understand that this is early stages, and what you're really demonstrating now is that it is possible, first of all, that you have this huge library of whatever number of people you have studied, and there's a library out there. And what you're doing really is, through this algorithm, comparing the way that Magda speaks with what is there in the library, which you have already classified into certain set of emotions.
And I'm special, let's be honest.
Of course you are.
Outlier.
And that's what we are going to test out now. And so what we would like to do, Magda, is assume for a moment that you sort of not quite happy with something that I did. And you know that I don't
have
respond.
to assume.
Okay. So that you can't get through to me by doing your pep talk and all that stuff. So that you're very seriously talking to me, like you're talking to me like I'm a 10-year-old or something of that sort. So in very measured, slow tones. Let us see how you're able to convey that to me. Ram, I don't quite like the way that you are handling it. The thing that you should do is this, whatever. Let's see what changes.
Ram, stop mansplaining to me how I should explain things to you. Let's maybe start there, okay? Okay.
Right.
God. Ram, so we need to have a chat about how you write emails sometimes. You are very smart and amazing, and I love you. But please, oh my gosh, please start using spell check. Sometimes I look at an email and I look at the content and it's all serious or insightful or I don't know, just something useful. And then there's no punctuation or there's no spaces between lines or there's like, I don't know, I kind of go, how do I even deal with you? You asked for this, dude. I'm just telling you how it is.
Okay, cut. So now you've got to introduce some more emotions of Magda is trying to portray. But anyway, there isn't much happiness out here, but there's a certain amount of greater degree of sadness which is coming through. So I guess, or seriousness or whatever it is. And therefore, probably that reflects some more. That's what really I was trying to check. And it does seem to be
Oh, is that
happening.
what it was? So you weren't trying to dig a hole for me?
No, I wasn't. I was just trying to get to the point where Magda can display multiple emotions, not just happiness and surprise for Sailor, but also sadness and seriousness about the way I don't always comply with Magda's wishes. So there we go. Okay, so now guys.
It's not so much Magda's wishes as common rules of communicating with other professionals. First of all, Ram. Second of all, where did the neutrality thing go? We had a neutrality thing here yesterday. I was excited to see if I could be neutral.
Satya, are we not going to be neutral anymore? We'll classify.
We can definitely.
Right, but right now I guess we don't. So that's the thing, right? When you can go a little more fine-grained than whatever we have done. So sadness, as Ram was mentioning, it could probably be broken down into seriousness and despair. Right now, what the AI was picking up was more of a seriousness tone, as Magda was expressing disappointment at the way Ram writes email. So neutrality. We can, so I don't know, like we can have the neutral tone, or we can have something like a monotonous sort of thing. But then you can classify that into different kind of emotions as well. So we'll see where it goes. I just want to address one question that a lot of people have been putting out. How does this benefit coaches? Yeah, so the thing is, you can, I see two uses of this. Let's say someone who's new to coaching and you want to learn how to modulate your voice while you're talking to someone you're coaching, someone who's under your guidance. This can absolutely let you do that. And imagine if you're good at understanding people, but you have a rather monotonous way of communicating, and you want to be more engaging so that you can connect with your mentees better. This helps in doing that as well. And it can serve the other opposite side as well. Like this can listen to the person you are mentoring. And even if they are sometimes not very open to, if they say something, but the voice says something different, an experienced coach, I'm sure, can easily catch that. Like if somebody comes in and you say, okay, how was your day? And you're like, yeah, it was great. I mean, anybody can see that, oh, the day wasn't great, but I just don't want to talk about it. But there are much more subtle aspects of it. There are much more subtle aspects of it. So that can reveal more things about the person who you are counseling. So it can be used in that way as well. And that's something we're working on right now. It's a multi-party conversation. The AI understands that here's two people who are talking. Here the emotions and engagement of one, and here's the emotion and engagement of the other. So the AI really makes that bond a bit more cohesive than it already is. So there's a lot of ways you can use this. And I'll quickly address the second most common question that I saw. Does it depend on religion? Sorry, not religion, region from where you're from, the language that you use? No, right now it doesn't. It mostly picks up vocal intonation. And Satya maybe will tell you how many languages we have fed into this AI. I don't understand, let's say, Portuguese. Or Mandarin, but if somebody is very sad and talking in Mandarin, I will be able to understand that that person is sad. And right now, that's sort of what the AI is doing. Even if it doesn't understand the words, it does pick up the voice tonality, and it can figure out that, okay, this person is sad. Satya, could you mention the different languages that have gone into training this AI?
Yeah, so we have fed in languages spanning from Estonian language to Urdu. So, and there is Mandarin, there is French, there is English, there is Hindi. So pretty much we have got all kinds of language, including Spanish both from the like the people from Spain and people from the other parts of the Latin American countries. So this we have actually fed in more than 30 languages to build this software.
Okay, there you have it. So yeah. All right. So when you, how does the AI process silence? Wonderful question.
Yes.
I love that question. I love that question. I think silence is one of the most important aspects of any language. I don't know the answer to that. I mean, I process silence in a certain way.
I'll try to take that question. Like finding out silence is one of the most difficult tasks of doing research in voice. So we don't have a very mathematical benchmark to what exactly silence is. And we have a mathematical benchmark for noise as compared to voice or music, but silence falls into that overall bracket of noise. So we do not know mathematically what silence is. We have a rough idea, and that's the reason we train in a lot of the AI algorithm with lots of data. And there was someone also asking, what is this background about? So silence and background has been coupled up in that entire bracket, where we take up silence and the other background noises, the urban noises, as a background class. So we wanted also to make sure that if there is a large amount of noise in the background, unfortunately the AI will not be able to catch up your voice. So if you can measure voice from on a scale of 0 to 1, and there is 80% background noise, then it is very difficult to process that voice in real time and tell you that what if there is an exactly a voice emotion entailed in that voice. So beyond 80% in real time, it is absolutely impossible right now.
Satya, I think Abhimanyu made a comment saying this is where
Yes.
coaches can help. I just want to clarify, coaches cannot help in that. I don't think any coach can really interpret what silence means. All that you're using silence in coaching conversations to provide the space for people to sort of explore the emotions come up with. But where I think it would be possible is if simultaneously, if you're also registering facial expressions or body movements and things like that, and those can be interpreted while the person is verbally silent, then maybe there are other indications which can happen because it's a non-verbal communication. So that might be a possibility in the future. But one other thing which is of interest is that Anita had asked a question about the genuineness of emotion. That is, the person is using happy words, but actually is sad. The voice indicates sadness, the energy level is low, or the other way around. So I presume one of the things that this can do is to really to show off the contradictions between these three elements, the famous experiments which have been done in verbal and nonverbal communications about the verbal usage, the tonality, and the body language. If there is a conflict, and if you're using all three measurements at the same time, and that could be extremely useful in showing up that, look, there is a contradiction out there. What's your opinion on that?
Yes, absolutely. So I always try to imagine the AI as how can we take the AI to be someone like an experienced coach. Like, of course, it will always be a great tool for coaches to use. But when we are developing something like this, what's the image that you have in mind? The image that I have in mind is a coach who's very experienced and very good at it. Now, either a coach or any human being, I mean, what are the signals that we pick up? Of course, the words, the way we say it, and our body movements. So it goes without saying that we are right now catching one aspect of something that drips emotion, which is the voice tonality. The words come next. That is our next goal, to put in the NLPs in there and figure out from the kind of words people are using, what kind of mental state they're in. And we have also already started working to a certain extent on that front as well. And apparently from the words that you use and also from the tonality, it's very easy to catch people who are depressed, people who are anxious. That can be done. And then comes a slightly more computationally heavy problem. I wouldn't say difficult, but computationally heavy problem, which is the visual processing. The human brain is incredible when it comes to processing visual information. A gigantic part of our brain is dedicated to processing what our eyes are taking in. So when you look at a person, when you look at their face, their hand, their shoulders, waist, everything, the way they're moving, there's a lot of processing that's going on in the human brain. So you have to match that and improve upon it. So once we have all the three pieces in place, then you have a brilliant device which is unfathomable in how powerful it can be. But there's still some time till we get there. We have put in the first peg in place. We are working on the second, and after that will probably come the visual interpretation.
Cool. So by the end of 2021, Coacharya is going to have a fully AI-empowered emotional intelligence bot. Yeah, cool.
Hopefully.
Yeah.
Crossed.
I was trying to catch you out to get it on record.
No, so yeah, okay. Let's look at what you have here today. Okay. Essentially, when we talked about this, the idea is to convey to a person who's speaking by measuring the emotions that essentially, I mean, in a sense, what you're measuring here, correct me if I'm wrong, this is what I understood in my earlier discussion with you guys. As Magda speaks, it's not so much the emotions that Magda is expressing, but the kind of emotions that would be evoked in the minds of the listeners based on the library that you have built. Or is it actually by comparing the way that she speaks with that library and say, hey, this is the emotions that she expressed while she was speaking? Which of it is correct?
The second one. But I can understand where the confusion comes from. The engagement is what's happening in the listener's head. The emotion is what's there in the speaker's voice. So for calculating the engagement, we had recorded brain activity of the listeners. And for gauging the emotions that are there in the speaker's voice, we have this whole library of 30 languages. So the emotions that were being displayed were the ones in Magda's voice when she was happy, or when it was showing sad, when she was talking about the email. That's what her voice had. But when you look at the engagement part, the engagement is how the listeners would be perceiving that entire speech or at that section of the speech that is going on at that point. So it's a combination of both.
Okay. So now if for a moment, let's assume my focus as a coach is to figure out the engagement, not so much the happiness or the sadness or whatever that I express, and I'm being pretty neutral right through my conversation. But I would like to see what that I'm saying is evoking in the client, which is what my end objective, which is what is being reflected by the engagement, I presume. So in this particular chart out there on the screen. So how do I interpret that?
So it is exactly what you said. So the chart shows that while she was speaking, what is the predicted level of engagement that the listeners, the entire audience, is putting in. If she were to be very boring and monotonous, that engagement level would drop. So that's actually the power of going out and recording, doing brain recordings in controlled experiments. It shows how the listener, the subject, the listener, I would say, it reveals something about the listener state of mind and not just the speakers. So if you as a coach use this tool and you're going through your counseling session, so yes, the graph that you see on the right hand side will tell you if what are the chances that the person you're talking to is actually even paying attention or listening to you, or are you sort of boring them, are you losing them? So that's what the engagement graph is giving you.
So it doesn't show, it doesn't indicate the kind of emotions that the person is feeling, but it shows the level of engagement, the bored rather than engaged kind of thing. So here in this scatter diagram kind of stuff, when it's showing between 0.4 and 0.8, what would the trend line look like? Where does boredom lie and where does engagement lie?
Right. So we're still standardizing that a little bit. We typically see, and Satya, just comment on this if you want. We typically see the population distribution lie between a little bit around 0.4, about 0.4 to about 0.6. Sometimes it goes up to 0.8, but 0.6. So that is the band that we see. So if it's hitting 0.4 or if it's going below that, then that's not very good. But if anything above 0.5, between 0.5 to 0.6, or sometimes even above, that we see are the rare instances when the engagement is high. Satya, if you can comment on this.
Yeah, so anything lower than 0.4, so the engagement level of the population of the listeners is very low. It usually ranges from for the data that we have, and we have quite a volume of data on this, from between 0.4 to 0.65, that is the medium band, and above 0.6, that's a very high level of engagement from the listener side. We haven't as of now seen something touching absolute one. So theoretically it can touch, but as from my experience going through a large volume of data, I haven't seen instances of a lot of instances of an absolute one touching. So
Okay.
So that's a challenge.
So that's a challenge.
I have a question though on that. So were there differences between genders? Seeing as women are known to be multitaskers and as a species. So I'm just wondering, like, were there differences in engagement between women and men?
Yeah, so with respect to women and men, like for the data that we have collected, women have a better engagement level to listening to the large variety of audio that we have given them. And so, and then we have to adjust the data based upon that. So once we figure out that, okay, my audience I would assume that there would be a balance between the male and the female population. Then we do the adjustment based upon the calculations of the population of the data that we have. But overall, if I were to separate the data and figure out that for a same voice signal, if a man would be more engaged than uh, a woman would be on the contrary.
And then somebody else was asking about instruments you use. Can you talk about like the actual collection method of the brainwaves?
Yes. So
Yes,
Shoma, would you
yes.
take that, please?
Yes, we dig electrodes into, no, we don't. So basically, it's a headset like this, and it has EEG sensors. So your brain is made up of billions of little cells known as neurons. Neurons are special because they have a different, so every cell is, you can imagine it to be spherical. And there's a difference in the electrical potential across the membrane. It's kind of like a battery. Sometimes what happens, there's a leak in the membrane and the potential difference goes to zero. So there's a lot of current that flows from the outside to inside. And that is what we call a neuron firing. And now when hundreds and millions of neurons fire at the same time, because you've seen a puppy, uh, that creates an electrical activity which can be detected from outside your brain. And now, depending upon which part of the head you're collecting the activity from, you can now figure out what that person was doing. For example, right here in the back of your head is the occipital lobe, where a lot of visual computations happen. So if you close your eyes, this part goes to sleep. You have high alpha activity in the back of your head. Alpha is typically called the brain is idling, like it's not doing much. So if you close your eyes, immediately in an EEG graph, you can see the alpha activity from the back of your head go up in power. Similarly, the frontal lobe is often associated with how focused you are. This is the prefrontal cortex. This is where all the executive functions are carried out. So now a higher beta activity, so alpha, beta, these are different frequencies of waves that you can catch, will show that you are really trying to focus on something. But beyond a certain level of beta power, you sort of go into an overload / stress. So these are the different cognitive aspects, and there are many, many such rules that have been figured out using a lot of EEG research. So we use a headset similar to this, but it covers more part of your head on subjects who come in and do various kinds of tests. And then we figure out what were they seeing, what were they hearing, and we correlate with what was going on in their head. And that's how we can figure out a lot of these correlations between external world, which can involve videos, audio, anything, versus what's happening inside the brain. So that bridge is gapped by powerful AI. So that's sort of what we do.
Soumya, a couple of things which have come up here. I would like you to take a look at that. One is Madhav's question, which is what I was earlier referring to. Can this listening engagement score be used to train the speaker on real-time basis to enhance the engagement? So if they have that, which I think is one of the things that we talked about. In fact, how do you train facilitators and trainers and speakers and so on and so forth, or even actors, for example, for them to be able to both engage and perhaps in future to be able to do. So that's something that can be done. Am I correct?
100%. That's one of the key use cases that we see of the engagement. Like here's a tool which tells you, even if you're standing, people stand and practice in front of the mirror, which is great. But now here's a tool when you're talking to the mirror. This tool is also telling you, yeah, you're doing a great job. If you speak like this, the audience will love it. They'll be enthralled by your voice or by the way you're speaking, as opposed to it's not doing so well. So it's a very powerful tool in order to learn to how to speak effectively, in order to how to catch attention when you're speaking. So yes.
So at the simplest level, it is one about the speaker to be able to, like if you're an actor, one of the first things that you learn is how to throw your voice. Here, how do you modulate your voice and so on and so forth in order to engage people better. And perhaps later try and discover through this two-way communication that you talked about that you would eventually get to, and through other means as well, that if this is the emotion that I'm evoking at this point in time in this person, is there another emotion that I can evoke by doing something different? So these are things which eventually this tool can lead to. The other question is from Susanna. The level of engagement is related to dopamine and to the reward response, but the reward response itself does not depend on the individual patterns. What is that? How do you answer that question?
Yeah, so the engagement level. So sure, look, dopamine as a neurotransmitter, it has various functions depending upon which part of the brain you're looking at. Basal ganglia and all, it drives motivation in that sense. But what we're looking at right here is a more fast-acting situation. For example, I talked about the prefrontal cortex. So in the frontal cortex and in the temporal cortex, you have a lot of these neurons, which are they're excitatory neurons as well as inhibitory neurons. So typically when you see something or hear something which grabs your attention, and it need not be pleasant even. We have this idea of dopamine being associated with a positive reward and pleasant. Even something very negative can catch your attention very, very quickly. Just listen to some of these people trying to sell things on TV and online. They shout like crazy, but it catches your engagement. So what happens is, I like to look at it from an information perspective, because so the brain typically is always trying to minimize surprise. The brain tries to have a map of the world such that it doesn't get caught on surprise. So anytime new information comes in, there's surprise, and the brain focuses its attentional resources in that direction. It's a very quick switch. Now, that is something that is picked up in the very fast activity in the frontal cortex and the temporal lobes. That is what EEG can pick up. Now, after having studied neuroscience, I can tell you, yeah, I mean, we know a lot, but there's a lot that we don't know. Dopamine associated with attention, yeah, of course it's there, with positive rewards, with basal ganglial system, with the limbic system, yeah, all that is there. But I'd like to look. So I like to look at it from the electrical perspective. So you can study the brain in a chemical perspective or an electrical perspective. So I like to look at the brain in an electrical perspective, where you have these very fast currents, which you see in the frontal and the temporal lobes. When you see when there's something new happens, when something that the brain wasn't expecting happens. Sitting and something's pleasant, you have a beautiful music, and there's certainly a car screeching outside. It's certainly not present, but your attention is going to go there, and there'll be a spike in the EEG that you can pick up on the EEG. So those are the kind of things that we are picking up. It would be unfair for me to correlate that with the dopamine system, because there's a lot to still know about the dopamine system. I can only talk about the things that I certainly know about. And in EEG, you can catch these very fast currents the moment you are attentive towards something, right? So that's how I would partially answer that question.
So going from there to something a little bit broader. So essentially, for instance, whether it's dopamine or serotonin or oxytocin or adrenaline or whatever, any of these neurotransmitters, any of these neurochemicals. Now, since you're using skull caps or EEG measurements and whatever, you are measuring certain parts of the brain excitement, as it were, and what's happened in neurons and so on. So would this be able to measure what kind of neurotransmitter is being released in the individual at that point in time through this measurement?
I would still classify that as a very difficult to answer question. Even in the highest spatial resolution fMRI, you can only talk about a part of the brain which is active, and not in terms of what neurotransmitter is released. But you can always talk in indirect terms. If you see, like, let's say, for example, a part of the brain called the hippocampus, which is a little deep inside, which gives us our spatial memory and also temporal memory. If it is active, so then you know that there are these positive dopaminergic neurons over there. There are these interneurons which inhibit currents over there. So using indirect knowledge. So look at it this way. In human beings, you can tell, okay, in this situation, this part of the brain is active. And then you bring in the information from model systems in monkeys and rodents and rabbits. So then you say, okay, this part of the brain, when it is active, it's typically chemicals X, Y, and Z, which activates it, and chemicals A, B, and C, which inhibits it. So that's how you would indirectly connect the bridge. But I doubt that you can see activity in a part of the brain and say, okay, that's just dopamine there, or that's serotonin that's being released. It'll have to be an indirect correlation like that.
Yeah, okay, I understand, because fMRI essentially is about measuring the brain, and the neurotransmitter, all of it need not necessarily be from the brain, and they are from your glands in various parts of the body, be it adrenaline, be it the thyroid, and so on and so forth. So it's going to be indirect. The reason why I asked this question is there have been, for example, theories, which I, in practice through my meditation and chakra energization processes and so on, I found it to be valid, is if I focus on my heart and sort of work on levels of compassion and stuff like that, then it enhances empathy, and perhaps this leads to a release of oxytocin in a much bigger way, the so-called nurturing chemical. Now, my question is, if supposing you were to put me in a skull cap and then measure, and I go into a serious meditation of the heart, what is called anahata meditation, or today they call the heart math, cardio meditation, would that be able to measure the release of oxytocin through the fMRI or the skull cap measurements?
It would not be able to measure oxytocin release, but it will be able to measure differences in your brain regions activity. So typically people say during meditation, these gamma frequencies, which are actually pretty hard to catch, they're very noisy. The gamma frequencies power increases in very deep meditation. So you can talk in terms of frequencies of brain activity. Again, here's the electrical perspective of the brain. Of course, there's a chemical basis to all of this. The chemistry changes, and therefore you see the electricity in the brain change. But right now, what we can do is we can talk in terms of the electrical activity. Of course, there's an underlying chemistry that's going to change. If you're meditating, your oxytocin levels are going to change. But again, it's indirect. We can't measure oxytocin. We can measure activity in the frontal lobe and the temporal lobe and occipital lobe. That we can do.
And in the parts of the brain where perhaps you would be associating it with empathy or compassion or those kind of things, that is possible, I guess.
It's possible. You could look at, you could look at the work of a very famous neuroscientist called Rebecca Sachs. She works on this RTPJ, right temporoparietal junction, which is somewhere here. And she studies how this part is very active in people who have high empathy, and it's very low active in people who have very low empathy, to the extent they have no idea what other people are doing or thinking in certain kinds of autistic disorders, where people are very awkward because they don't know what the other people are thinking. They don't have a good theory of mind, is the term. So, and then you see the change in activity in the right temporoparietal junction. So yes, if you were doing an fMRI, you could see that the temporoparietal junction, RTPJ activity differ under different circumstances. So again, but you'd be talking about parts of the brain which has an underlying chemistry, but we can't comment on the chemistry. We can only comment on the parts of the brain being more active or less active.
The last question we'll just take, Devrajan's question. Curious to know how the tool factors neurological ailments like epilepsy, Parkinson, Alzheimer, etc., where the brain activity is much different. I mean, it's not related to coaching or anything, but is that an area where this can be used?
Sure. I mean, but it's already being used. See, epilepsy you can detect using EEG very well. Parkinson's and other kinds of dementia, unfortunately, only when the Alzheimer's and other dementia, when the disease proceeds to a great extent, then you see a very different. The activity is very different that you pick up. But the thing is, you'll behaviorally notice that much before. If somebody is forgetting, okay, which way is my bedroom, you'll notice that way before that you actually pick it up in the electrical activity. But these are research that people have done. I might add a little bit. It's an interesting trivia. So nowadays what people are doing, people who have high levels of epilepsy, sometimes they have electrode surgically implanted in the region of the brain from which the epilepsy is arising. And now using AI, even before the epileptic activity starts, the AI can predict after 15 to 20 minutes an epileptic activity can start. So please go to a safe location, don't cross the road, sit down, be with your caregiver. And add to that, I read reports that you can even do certain kinds of stimulation to reduce the chances that the brain is going to go into that epileptic activity. So that's the state of the art that neuroscientists are working on when it comes to epilepsy and all of these things. Detection was like a decade ago or 2 decades ago using these kind of things, right? So that's yeah.
Okay, Magda, all yours to close. Thank you very, very much, Satya, Soumya. It's been wonderful. And I'm sure as you progress, as Magda said, we would like to be one of the first to try and use your system in coaching. We are hoping to do that. So we'll have you featured probably again and again. Magda, over to you.
Yeah, and let us know when you want, when you have an open kind of demo beta type thing, so we can share with the audience. And yeah, I'm gonna play with this some more, because I'm just thinking, like, I also was being swayed by seeing the screen, and I couldn't minimize it because we were sharing it on Zoom.
Yeah.
So I wonder how it'll be if I'm doing, like, maybe Ram, you and I, next time we have our Monday chat, we can record it and see how angry I get with you.
Yeah, the challenge would be, without Ram triggering her with emails and stuff, how Magda can still explode and be able to register emotions such as sadness and disgust and all those kind of things. So that would be
I have
when...
emotions.
Okay, of course you do. So I don't have to trigger them. So if they are able to come from someplace else and we are able to do that. So let's see, from these 5 emotions that you have now, background, neutral, sadness, happiness, disgust, and so on. Once you have those 20 or 25, like an atlas of emotions people talk about. So if you can get that, that'd be something truly be fantastic. Thank you.